got another trig identity up here on the board. I want to prove that tangent squared x over secant squared x is equal to 1 minus cosine x times 1 plus cosine x. Okay. And here I'm going to show you what I call the 3-paragraph method. Remember, the rule is that we're only allowed to work with one side at a time. So I can work with the left-hand side, and I can talk about that. Or I could work with the right-hand side, and I could talk about that. And in the 3-paragraph method, what I'm going to do is my first paragraph, I'm going to simplify the left-hand side. Then I'm going to switch, new paragraph, talking about the right-hand side, which I will not connect with an equal sign to the left-hand side because I don't know they're equal yet. But I'm going to try to simplify them until I get the same thing. And then my third paragraph is to say, oh, look, they're the same. Okay. So I'm going to just choose to work with the left-hand side first, although it doesn't matter. I could work with either one. And I think I'm going to try the same strategy that we used last time of just writing everything in terms of sines and cosines. So the left-hand side was tangent squared x over secant squared x. And I could say, well, that's sine squared x over cosine squared x all over 1 over cosine squared x. And now again, if I'm dividing fractions, I'm going to flip and multiply. So this is going to be sine squared x over cosine squared x times cosine squared x over 1. That's going to cancel, and I get sine squared x. Now at this point, I might or might not see how that's going to relate to the right-hand side, but I've simplified that pretty far. I think I actually have to make it more complicated to make it look like that. Okay. So if I get to a point where I feel like, I've simplified that side as much as I can, so either anything else I do would make it more complicated or just I don't see what else to do, then I can switch and start talking about the right-hand side. Okay. Now, you'll notice I had equal signs all throughout here. And in a proof, you got to write those equal signs. You can't just say, here's this, here's that, here's that. The proof is demonstrating that they're equal. I want to see those equal signs. Okay. So now I'm switching to talk about the right-hand side. New paragraph. This is not connected to the stuff that came before it with an equal sign. Okay. If I were writing an essay, I would indent. It's a new paragraph. Okay. So it's not connected to the stuff that came before it. Okay. And I can say the right-hand side, that is equal to 1 minus cosine x times 1 plus cosine x. And I'm going to just do the multiplication. I'm going to FOIL that out. So that's going to give me 1 from my first terms, plus cosine x from the outsides, minus cosine x from the insides, and minus cosine squared x from the last terms. These guys cancel, so that's going to give me, notice I'm still connecting it with an equal sign, that's going to give me just 1 minus cosine squared x. And I recognize from my Pythagorean identity, if I need to write it out off to the side, I can. Remember, sine squared x plus cosine squared x equals 1. And so that means that sine squared x is 1 minus cosine squared x. So I can say, hey, that's sine squared x. So I've simplified it to the same thing that I simplified the left-hand side to. Okay. Not okay to just stop there, though, because then you're asking whoever's reading your proof to sort of figure out why you stopped. You want to just be kind to your reader and say, oh, look, left-hand side equals right-hand side. Okay. So that's why I called this the 3-paragraph method. Here's what the left side simplifies to. Second paragraph, here's what the right side simplifies to. Third paragraph, oh, look, they're the same. And then you're done. Okay. So there I did work with both sides, but I only worked with one side at a time. Now, I want to just show you one thing that some of you may have seen people do, and a lot of people do this, and it's really just sloppy notation. So I want to tell you that it's not acceptable in my class. Some teachers will accept this. I don't. Some people will say, let's just do this. Let's put a bar here and write the 1 minus cosine x, 1 plus cosine x. And they're essentially doing the 3-paragraph method, but they're doing it as the 2-column method. So they're simplifying the left side over here and the right side over here. Okay. I don't want them right next to each other like that. I want it to be clearly separated. This is my work with the left-hand side. This is my work with the right-hand side. It's too easy when you're writing the left-hand side next to the right-hand side to think of this as an equation and do the same thing to both sides. So I don't want to just see you taking a table and simplifying both sides. I will not consider that acceptable notation for your proofs. Okay? We'll come back and we'll practice some more.